Hi everybody, Mrs. Jennings here, and we're going to take a look at our Unit 9 review sheet. So again, our unit this whole time was about probability, and the trick is going to be remembering whether we're looking at the total probability, whether we're looking at a given situation where we're restricting that denominator, or whether we're even looking at just a count and not the probability at all. So let's take a look at our examples here. So problem number 1, a drawer in a jewelry store has 8 watches, 7 bracelets, and 5 necklaces. Find the probability. So again, step 1, we didn't have a total here, so that's going to be your first step. Let's go ahead and find that total, which should come out to 8 plus 7 plus 5, that should be a 20. So there are 20 items in that drawer. So the probability of a watch, again, there's no restriction on my denominator, so the probability of a watch would just be watches, which in this case is 8 over 20. Now remember that when we're doing this, we want to make sure that your fractions are either in reduced form or as a decimal. Okay, so 8 over 20 is going to reduce down to 2 over 5. Probability of a bracelet. Again, we've got 7 possibilities. There are 20 total in that drawer. That one's not going to reduce. Probability that it is not a watch. Well, we've got a couple ways to do this. Remember that the original and the not was what we called a complement. So I could take 1, the whole, and get rid of the watch, and that would leave me with 3/5. So I could use the idea of complement. The other way that you can do this, right, if we don't remember the complement and it's something like this, you can also simply look up all of the items that weren't watches. So 7 and 5, there were 12 items that were not watches, so 12 over 20, which would also reduce down to that 3/5. So you can think about it either way. Same idea here, probability that it's not a necklace. Well, we haven't found the probability of a necklace yet. So on this one, it might be easier just to go ahead and count everything else. So the probability of a necklace, there would be 5 of those, which means 8 and 7, I would have 15 other options that were not necklaces. And that should come out to 3/4 reduced. All right, number 2, we're going to look at a spinner. If we're going to notice, our spinner has 5 options. Okay, again, none of our information is talking about a given. We're not restricting our denominator in any way, so our denominator is going to be 5. So the probability that we get an odd number, well, 1, 3, and 5, those are all odd. So 3 out of my 5 spaces are going to be odd numbers. The probability that it's not odd, again, these guys would be what we call complements. And a complement means that I can either count, which you absolutely could, or I can take 1 minus the other one. So if I want the probability that it's not odd, that would be the whole 1 minus 3/5, the one we just found. So 2/5. Or, again, if I count, the probability that it's not odd, those would be my even numbers, and again, they would be my 2 over 5. So you can think about it either way. Probability of a 4. There's 1 4 on this particular spinner, so 1 out of 5. Probability that it's not a 6. Well, again, I want not 6. None of those numbers are 6s, so that's a sure thing. 5 out of 5, which is the same thing as a 1. Probability that I get less than or equal to 4. Well, less than or equal to, I would have the 4s, 3s, 2s, and 1s. So 4 out of my 5 spaces should give me a probability less than or equal to 4. All right, then we'll look down here at number 3. A fair coin is tossed, and then the spinner from number 2, so this guy, spinner from number 2 is spun. All outcomes on the spinner are equally likely. List the sample space. So if you remember, sample space had that funny notation. We had to use those squiggly brackets, and then every possibility was listed with a comma in between it. Now, you're absolutely allowed to organize this any way you want, but when we write out sample space, it had to be in that notation. So a fair coin means that I either have heads or I have tails. And then my spinner has the possibilities 1 through 5. So my sample space means that I could get a head and a 1, head and 2, head and a 3, head and 4, or head and 5. Or I could do the same thing with my tails. I could get tails and 1, tails 2, tails 3, tails 4, or tails 5. So your sample space, remember, that was those squiggly brackets, and each element was listed inside and had a comma in between. Now, once you have a sample space, you can absolutely use it to find your probability. So yes, you can use your formulas, or you can look. So find the probability of tails and landing on a 3. So remember that in and, that's going to be my overlap, which means that in my sample space, it has to have a tail and a 3. So as we look over here, the only one with a tail and a 3 is right there. So my probability here is a 1 out of 10. Now, we also talked about that we could write that, right? This would be the probability of tails and 3. Well, and was multiplication. So the probability of tails, right, in heads or tails would be a 1/2. The probability of getting a 3, there's 1 3 out of 5 spaces, so 1 out of 5. And if you notice, if we multiply straight across, again, we're also going to get a 1/10. So you can absolutely count, or the formula absolutely holds true as well. All right, if we look at this next guy, find the probability of heads or landing on a 3. Now again, I can look. So the probability of heads would be each one of these that had an H in it. All right, so I've got 5 possibilities with an H, or landing on a 3. So of the ones that are left, I've got one more option that has a 3. So if I just use my sample space, I would get 6 out of the 10, which again, that's going to reduce down to 3/5. So I can just use sample space. If you want to use the formula, right, the probability of an or means that I want the probability of heads plus the probability of a 3, and then I subtract out the probability of heads and 3. That's your formula. So the probability of getting a head would be 5 out of 10. The probability of getting a 3, there are 2 of those, so 2 out of the 10. And the heads and a 3, well, there's 1 of those, so we get rid of the 1/10. So if you notice, 5 plus 2 would be a 7, minus 1, I'm going to get 6/10, 3/5. So again, you can do it either way. Either way on that one. Part D, find the probability of tails and not 1. All right, so the probability of tails, right, 1, 2, 3, I've got 5 possibilities of a tail, but they cannot be a 1. So this tails 1 is gone. So of my options left, that should be a 4 out of a 10, which again, that's going to reduce down to a 2/5. All right, then we look at this next one. So number 4. Some of the students in grades 9 through 9, 10, and 11 have smartphones. Complete the table. So on your tables, again, they're called two-way tables because we go across and we go down to find our totals. So as we add going across, this one should come out to 105 and a 45. And when I put those together, there's a 150. My columns, as I go down, here's 37. This guy should come out to a 48, 65. And then again, my check, as I go across, it should also come out to a 150, which hopefully it does. Now, as we're looking at this, we're going to take a look if an 11th grade student is chosen at random. So again, this is one of those ones where it doesn't explicitly say given, but next to that if, right, I don't want to look at my whole table. For this one, I'm only looking at my 11th grade students. So I've restricted my table down to just that column. So if an 11th grade student is chosen at random, right, so my denominator is going to be a 65, what's the probability that they have a smartphone? So only looking at that column, right, smartphone is 45. Okay, so again, we can punch that on the calculator. 45 over 65, that should come out to a 9 over a 13. Then we look at the next one. If one of the smartphones is selected at random. Okay, so again, I'm not looking at my whole table. I'm only looking at smartphones. So as I go across, here's my green. I'm only concerned about that row. If I choose one of the smartphones, what's the probability it belongs to a 10th grader? So again, in this row, 10th grade is right here. So there are 32 10th graders given that I was selecting from somebody that had a smartphone. And I'm pretty sure 32 over 105 does not reduce, but let me double check that. No, so that one's going to stay the same. Again, as a fraction, so again, if you're rounding, going out 2 decimal places would be 0.30, give or take. Okay, part C. What's the probability that a student is in 10th grade given, now again, givens are the nice ones, right? When it obviously says given, that makes it a little bit easier. Given that their smartphone, that their phone is not a smartphone. So when I have a given statement, remember that that immediately tells you what your denominator is. So this one, I'm looking at the not smartphone row. So my denominator is going to be 45, and we would like the probability of a 10th grader. So again, in the pink row, 10th grade is going to be the 16. 16 over 45, and again, I'm pretty sure that one does not reduce either. No, so that's going to be the same. Again, if we round it out, that would be 0.35. That one rounds. So again, to the hundredths place would be 0.36. All right, number 5. A fair coin is tossed, right? So fair coin, again, that just means we've got heads or tails and they are equally likely. And the spinner below is spun. Find the following. Okay, so we're going to think for just a second, right? If I'm tossing a coin and I'm spinning a spinner, they're independent, right? If I toss that coin, it does not impact that spinner at all. So when I'm looking at my probabilities here, I can either kind of think through them or I can use my formulas. So the probability of tails and a C. Well, the probability of, again, if they're independent events, this is equal to the probability of tails multiplied by the probability of getting a C. So tails would be a 1/2. The probability of a C would be a 1 out of 4. And as I multiply, again with fractions, we go straight across. So my probability of tails and a C would be a 1/8. Now on this one, the tails or C, right? Again, if we've decided these are independent, right? There is no overlap here, right? There's no way that I can have the coin and the spinner like be the same thing at the same time. It doesn't work. So remember, this is what we called mutually exclusive. Right? Which meant that there was no overlap. There is no and here. There's no way these things overlap. So if I have an or, it's the probability of tails, and I add the probability of C. So the probability of tails was a 1/2. The probability of C was a 1/4. Now remember that when we add fractions, which you're welcome to just do on your calculator, right? But they would have to have a common denominator. So I would have 2/4 plus 1/4. Again, your calculator can do it for you, but you should wind up with that 3/4. All right, then we have the probability of heads or tails. Okay, well, again, heads or tails, the probability of heads is a 1/2, probability of tails is a 1/2, and that comes out to a 1, which should make sense to you. If I flip a coin, I have to get a head or a tail. Those are my only options. Okay, and then my last one, the probability of tails and that I get A or B. Okay, so again, this is an and. They're independent events, so I can multiply. So the probability of tails was a 1/2, and if I look at my spinner, the probability of A or B, well, that would be 2 out of 4 possibilities. All right, so again, when I multiply, I can go straight across. I'm going to get 2/8, which comes out to a 1/4. All right, and then our last one on this page, number 6. We've got a Venn diagram here, which is showing the number of students who have at least one brother or sister, both or neither. So again, this has not been explicitly said, but remember that if it's outside those circles, that's your none, which in this case would be somebody that doesn't have a brother or a sister. We're also going to notice they don't have a total. So again, your first thing that I would suggest doing is let's go ahead and find that. And we're going to add everything in the Venn diagram. So 95, 110, 98, and 47, which I'm getting 350. Okay, so we go back to our problem. Now, notice that this time it says how many. Every other problem we've done so far, it has said the probability of, or it's had that capital P in it. If it's how many, this is a count, which means you don't have a denominator. We're just counting. So how many students have at least one brother or sister? So on a Venn diagram, that's everything. So it's everything in the brother category, and it's everything in the sister category. And we just don't count that 110 twice. So I'm going to have 95 that just have a brother. I've got 110 that have a brother and a sister, and then I've got 98 that have that sister. So again, we just add everything together, and that should come out to 303. Now again, it says how many. So that's not a probability, it's just a count. So if I look at my Venn diagram, it wants how many students have at least one brother and sister. Well, now and is the overlap. That's the portion where the circles overlap. So there are 110 students who answered that they had a brother and a sister. Okay, which means if we were thinking, again, just to use our vocabulary, these events are not mutually exclusive because my circles aren't separated. I have an overlap here. I have an and so therefore there's some sort of dependence in there. Again, we've got how many. How many students have at least one sister and no brothers? Okay, so I look at my sisters, right? And the 110, that's that overlap. So if I cover that up, I've got 98 okay, that are just sisters. Then we've got how many students have no brothers or sisters. Well, that's that none there at the bottom, right? So again, this is a how many, not a probability, a how many. So there are 47 that don't have any. Okay, and then again, our last question here, how many students do not have brothers? Well, that would be, if I don't have a brother, that would be nothing in that brother category. So the numbers that are left would be a 98 and a 47. Okay, and when we put those together, that should come out to 145.